Hi everyone. In this video, I'm going to be going over the hands-on labs from Chapter 13. This is from the CCNA Routing and Switching Study Guide written by Todd Lamel. Chapter 13 is all about NAT, Network Address Translation. So to do this lab, I have built up a little test lab in Packet Tracer using this IP addressing scheme. Mine does vary slightly in that I'm using serial interface 1 rather than 2 and gigabit Ethernet here instead of just Ethernet. But my IP addressing will be the same, so if you want to set this up on your end and kind of follow along, this is how I'll be doing this. So I have the 171.16.10.1 here on the ISP, 10.2 here on Lab A, 20.1 here on Lab A, and 20.2 here on Lab B. And then this side, which is my gigabit Ethernet side, is the 30.1 network. So 30.0 network, so 30.1 here and 30.2 here. So you need to go ahead and pause this for a moment and finish getting your network set up, and we'll go ahead and continue. So as I mentioned, Chapter 13 was all about NAT, so we're going to start. We want to configure and test dynamic NAT. In order for network address translation to occur properly, we need to have some kind of routing. I haven't configured routing yet. We're going to just set up a basic RIP, so we can see that directly connected routers can communicate, but I don't have any kind of routing through my routers. So to begin, we're going to start with Lab A. And we're just going to configure router RIP. Go ahead and give it the network commands. And then we're going to set up a passive interface over my serial 001, which is to my ISP, because my ISP doesn't need my RIP updates. Then we're going to go ahead and give the exit command, and we're going to give one more. We're just going to be an IP default network. There we go. And it'll be the 171.16.10.1, so the IP address on the interface pointing to my ISP. This advertises a default network to my other routers, so they know how to get to the internet. And then we're going to go ahead and configure RIP on the Lab B router. And it's very similar, router RIP, and then the networks. So we have 20.0 and 30.0. And then the Lab C router only has a single network, the 192.168.30, so that's the only one that we will inform it of. 30.0. Alright, and then on our ISP end, we're just going to create a default route pointing back into my network, my LAN. I'm going to make sure that is 0. I think that, yeah, it is 0, not 1. Alright, and then we want to go ahead and configure our ISP so that we can telnet in. The book says to do it so you can telnet without being prompted for a password. To do that, we would do the command line vty 0 space 4, and we would just give the no login command. I've noticed that doesn't work very well in Packet Tracer, so I'm just going to go ahead and set up a basic password, Cisco, and give the login command, so that I'll be able to log in and actually use the router from a telnet connection. Alright, so the next thing that we want to do is to configure our dynamic NAT. So we want to do this on our actual gateway to the internet. And the first thing we want to do, I'm going to go ahead and save right here. I'm going to go ahead and save everything. And save one more time. So we have our routing protocols up and running. But if we look at one of these packets, as it passes through the lab A router, it just gets routed through, and it keeps our public or our private address as the source. And we can verify that by showing how even the ISP is getting this source address that's our private address on our LAN. And so NAT is going to translate that into a public address that's routable across the internet. So to begin with lab A, we want to create a pool. So it'll be IP and well, let me get to global configuration mode here. IP NAT pool. You need to give it a pool name, so I'm just going to call it global. And then you want to give the addresses that you own, the public addresses that you can actually use. So for this example, I'll be using these addresses. So I've got those 6 addresses there, and I need to give it the netmask command, and we're going to treat these all as just a generic class C, so that everything fits in with our IPv1. Once we have that pool created, we need to create access lists that will permit these networks to be translated. So we do that with the command access list. We need to give it a number. So this is just going to be a standard list. I'll call it 1. I want it to permit everything from the 192.168.20.0 and then the wildcard mask. So we'll permit everything from that network and our 30.0 network. Next, we want to map this access list to the pool that we just created. So we give the command IP NAT inside source list 1 because we used 1 here. So these will need to match. If I used access list 25, then obviously I would want to match that here. And map it to the pool global. Alright, so the next thing we want to do is to configure our inside interface and our outside interface, which on lab A, our inside interface points directly back to our LAN, which is going to be serial 000. And then I want to tell it that the outside interface, serial 001, so it knows how to translate those correctly. And then I should be able, from my lab C router, I should be able to telnet now into the ISP. And I'm in. So I know that my routing protocols are working, and I verified those with some basic pings. And then I'm going to go ahead and do the same thing from lab B here. So they're both connected now through a VTY line. to set an enable password. So that I can actually come through my VTY line. And I want to see how these two are connected, so I'm going to give the command show users. And so I have the asterisk on the line that I'm connected to, and there's the address it's showing for me, which is an address from that pool that we created, .50 through .55. So the lab C connected first, and it got the first address out of the pool, and then lab B connected and got the second address out of the pool. So lab C was actually a 192.168.30.2, and so that shows us that our NAT is working correctly and translating correctly for our internal devices. So now we want to go ahead and connect over to the lab A so that we can see what translations have taken place, just to verify. So in lab A, we will give the command show IP NAT translations. And this lets us actually see our inside global, which is the address that we're translating it into. The inside local is the original host, the source host, actual IP address. And our outside local will be this router's interface to the internet. So really we can see that we mapped 30.2, which is lab C, to 10.50. And then we did 20.2, which is lab B, to 10.51. So that's a good way of just verifying that it has happened. You can also turn on a debugger. So we could give the command debug IPNAT. And then when we ping through the NAT translations, we'll actually get notifications. So we'll let that travel back and complete the ping process. So we see it outbound and coming back inbound. Keep in mind that debugging does take a little bit of processing power, so it's great to verify that it's processing correctly, but once you're done, you usually want to turn debugging off, and you can do that with the no debug IPNAT command, or you can just do undebug all. Alright, so that's kind of the basics for dynamic NAT. Next thing we want to do is configure PAT, port address translation, and that is why I saved this earlier. Because now I should still have all my routing protocols and not have to reconfigure them. Might take a minute, but make sure all my routing is working and verify that I don't have any kind of NAT. Alright, so it's keeping my private address, even sending out to the ISP, which usually isn't a great thing. So now we'll go ahead and configure port address translation. And it's fairly similar. We're going to be doing this in lab A again, which is the last router that we actually can configure before our network traffic reaches our ISP. And so, let me come back really quick. Just to make sure, we want to go ahead and clear IP NAT translations. With the asterisk for the wildcard, meaning all. If you still had your dynamic NAT enabled, you would want to remove that pool. No IP NAT would need to come up. No IP NAT pool global. And then both IP addresses. And so on and so forth. Once you've removed the pool, you would want to give the no IP NAT inside source list 1 pool, so you remove that as well. And then we're going to go ahead and get started on actually creating the PAT now. So we want to, again, we'll be creating another pool, and let's call this overload. And we're going to give a single public address. With a net mask of a class C. Next we want to go ahead and create an access list for this as well. So we'll create access list 2 in this case, and tell it to permit the 192.168.20.0 with a wildcard mask, and the 192.168.30.0. And we want to go ahead and map the list to the pool. And give the command overload at the end. So overload is my name. It's just a name. This could pretty much be anything that you specify. Overload here on the end actually specifies to the router to use port address translation with this single public IP address. Alright, we want to go ahead, since we've removed all of our configurations, we want to go back into our interfaces and reset our inside and outside interfaces. So again, our inside is going to be 0, 0, 0. And S001 is going to be our outside. And we want to make sure that we can telnet into here again, so I'm just going to verify that. Alright, and then we're going to go ahead and telnet again from C, and then again from B, and that way we can compare how our port address translations are actually happening and view the different values there. So we give the command telnet, T-E-L-N-E-T. We want to telnet over it into the ISP router, which is IP address 171.16.10.1. Go ahead and put in our passwords. And then we'll do the same thing from lab B. Telnet 171.16.10.1. Cisco enable Cisco 1. And that way we can make sure that we're in. And then we want to go ahead and give the show users command again. So we have the VTY line that we're currently on from lab B. And we see that we're showing the 10.100. The lab C router on that VTY line is showing the exact same address. And so in lab A, we actually want to double check our NAT translations. with show IP NAT translations. And we have the lab B router is 10.100 at port 1024, while the lab C router is 10.100 at port 1025. And so we're really overloading one address and identifying that each port then is actually a different host on our network. And if we wanted, we could also do the debug again and actually see it happen in real time. I don't feel the need to do that because I can see that it's working. One thing we might go ahead and do is just to send a ping across and actually look at the packet information here. And so this is the outbound, so it'll be coming out to the ISP. We see that it's changed the address to 10.100, which we specified. And that's another way of verifying that NAT overload, or PAT, is working correctly. Looks like that covers pretty much everything for NAT. As always, if you have any questions or comments, please feel free to leave them for me below. I will try to reply in a timely fashion. Thank you so much for watching, and I hope to see you in my next video.